Okay, this is 7.4 video, the postulate for similar triangles. This is objective 1 part A. The AA, that's angle, similarity is postulate. Okay, so we're just gonna do one postulate in here, and then 7.5 we do other theorems. Okay, so warm up. First, try making similar but not congruent triangles with extra polygon sticks. So you don't have extra polygon sticks at home, obviously. But think about what makes triangles similar. So you remember, if the triangles are similar, first of all angles are congruent, right? And second of all sides are what? Proportional. Okay. So the easiest way to make a similar triangle with extra stick would be to make two equilateral triangles that are different colors. But you get the idea. So you make the three angles the same, but lengths are different, but proportional. Then you got the similar triangles. So what makes the triangle similar? So what, this is three angles and three sides, right? But just like to make triangles congruent, you don't have to have all three sides and three angles congruent to prove the triangles are congruent, right? For the similar manner, to prove the triangles are similar, you don't have to do all three angles and all three sides proportional. You just have to do certain number of angles and certain number of sides proportional to make them similar. So I want you to think about that a little bit. And then we're going to go into this packet and we prove one of them. And then there are two others that are in 7.5. Okay? All right, so here we are. We are in 7.4. And so objective 1 has AA similarity postulate and the side angle side similarity theorem and the side similarity theorem to prove triangles similar. So these we are doing in the next packet. Okay, so use the AA similarity postulate to prove triangles similar. Oh, sorry, couldn't see. Use the angle similarity postulate to prove triangles similar. Okay, so here is the similarity postulate. Draw any two segments AB and A dash B dash. Draw any angle A and congruent angle A dash, and draw any angle B and congruent angle B dash, and label point C the intersection of those two lines, and then these triangles are similar. Measure each pair of corresponding sides and compute an approximate decimal value of the lengths, and then all these lengths are proportional. The ratios comparing step 3 approximate in the same. Okay, so if these are in fact drawn properly with the same angles, by the way, if two angles are congruent, then the third angles are also congruent, right? You remember that. And to make the triangle similar, if the three angles are congruent, then they are similar. Don't have to be congruent, but they are going to be similar. But since you know that if you know the two angles, the third angles are congruent, you don't have to know three, you just have to know two. And once you know the two angles are congruent, the triangles are similar, then sides should be proportional. We are not going to do this measuring thing. We're just going to go straight to the proofs. Okay, so the postulate, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so given the H and F are right angles, prove that HK times GO is FG times KO. Okay, from the proof, you can prove that this if these proportions are correct, and you can do this if the triangles are similar. Okay, so that's example 1. I guess we are not proving them because this is a postulate. We can't prove it actually. Yeah, so this is accepted as truth. That three angles are congruent, then triangles are similar. But since if you know two angles, you know the third angle, so you just need to know the two angles. Okay, All right, so let's do the example 1. So the Plano proof is to make these triangles similar, then the proportion is going to be equal, then these cross multiplied products is going to be equal, right? So you got the one right angles and these are vertical angles, right? So these triangles are similar. So you can set up a proportion and you can see this. So I'm just going to do this for you since this is the first one. Let's do it together so you know how to write these kind of proofs. Okay, so 1, angle H and angle F are right angles. That's given. 2, angle H is congruent to angle F. All right angles are congruent. 3, angle KOH is congruent to angle FOG, vertical angle theorem. And 4, triangle HKO is similar to triangle FGO by AA similarity postulate, right? So then 5, we want HK over FG. So the HK is this side and FG. So the H and K, H and F corresponds, right? H and F corresponds, and O and K and G corresponds. So K and G correspond. Make sure you do it in the right order. Equal KO over GO, and corresponding sides of similar triangles are proportional. Okay, I'm not going to really abbreviate this. Corresponding sides of similar triangles are proportional. You have to spell out. So in 6, HK times GO equal FG times KO, and this is the cross multiplying property of proportion. Okay, yeah, and we are done. Okay, and on next page here. Okay, so here are some practice problems. So let's see. If these triangles are similar, tell whether each statement must be true. So I'm going to do this one. This is true or false, right? So actually, you should do all of them. All homework should be quick, hopefully. Okay, and 9, one triangle has angle measure of 37. So let's do 9 and 11 as a homework as well, and let's do 10 in the video. Okay, and then I probably assign something. Oh, there's a 12 and 13 too. Okay, so we have to do these, and then I don't know which one I'm going to assign for the video. It may be one of these, okay? Depending on how tricky they are. Alright, so 10. Name all the pair of congruent angles in a figure. Oh, that's kind of silly, right? So these are congruent, and these are congruent, and that's pretty much it, right? Because these are congruent and these are congruent, but then these are parallel anyway, so these are corresponding angles. Okay, I'm not gonna write that out. Okay, so you can do the rest. Let's look at 12. Suppose you want to show that where's AB? YZ. Oh, does this go with this one? No, I don't see AB. Oh, I guess this doesn't have diagram. What are the sum of the proportion that is equivalent to that equation? Suppose you want to show, okay, so if these are equivalent, right? This times this is this times this. These are means and these are extremes, right? So this is mean and extreme. So when you do a fraction, mean is gonna go here, right? The middle two, and the extreme is gonna be first and last. So AB and YZ. No, I'm sorry. No, I'm sorry, that's not right. These are, this is the product of the mean. Sorry, these are not. This, if this was the proportion, right? Proportion to proportion, then that's mean and extreme. But this is cross multiplied. Okay, so this is the mean and this is the extreme. You see the difference? This is multiply, no proportion, right? So the mean equal extremes. So you have to put these YZ and extreme CD WX. So this cross multiply this and these are congruent. But you can also put this one, swap here, the same thing, AB and YZ, and if you put WX here and CD here, the cross multiplying products is still the same. So this is equivalent. Anything that you do is like CD over YZ equal AB over WX. Let's try it. CD over YZ equal AB over WX. You still get AB times YZ and CD over WX. So any of these would work. Okay? And for the same token, you can do AB over CD equal WX over YZ. I just flip this top and bottom, and then it's still the same. You can flip this one too. So AB over WX equal CD over YZ, and cross multiplying still holds. So this can give you so many different, there may be more, so many different cross multiplying opportunities. So when you see a proof that prove this, you can do any of this. Okay? All right, let's look at 13. Cecilia wanted to find the length of a certain tree for a report in her biology class. Her method used shadows as shown in the diagram. She measured the shadow of the tree and found it was 5 meters long. She measured her shadow and found that it was okay, so ST is 5 meters and SC is 0.8 meters. And so this is 90 degrees and this is shared, so these two triangles are similar. So you can set up a triangle similarity, and then you can do the proportion, and you can see how tall the tree is. So do the rest as a homework. Okay? And you're done with the video.